Hello ladies and gentlemen, welcome to our Siemens tutorial. Differences between electrical panels like industrial control panels, switch and panel boards, and motor control centers, also well known as MCC for the US market. My name is Maximilian Krehan. I'm a technical consultant for North American safety standards concerning electrical equipment of industry machinery. During our international electrical safety standard trainings, we often noticed that the terminology of all these cabinets is used very diverse. This causes sometimes confusions and misunderstandings between OEMs, electrical engineers, and operators of these panels. This tutorial will highlight the details and the differences between all these electrical panels for the North American market to clarify what is a proper electrical panel for the desired operator application. At the glance and from an outside perspective of all these cabinets connected together with or without transformer to supply loads look very much alike. Most of them are metal enclosure with electrical components mounted inside. And you know what? They have more in common. These electrical cabinets, like panelboards, switchboards and switchgears, are in general distribution boards, all equipped with integrated bus bars for power distribution. And they are all covered in the same NEC chapter 408. These distribution boards are all designed to distribute electrical power in buildings. So the line side of them get the power directly from the utility energy company or either from other distribution boards and transformer in the building. These distribution panels supplies low voltage loads which are typically installed in buildings like lightnings, heaters, receptacles and air conditioner. But I also want to talk about other electrical cabinets used for industrial applications, which also look pretty like these distribution boards. Here you see an enclosed motor starter as an electrical cabinet, also direct supplied from the switchboard, which contain all electrical components to control and to protect a single industrial motor. It looks really like a little panel board, but there's no bus bar system inside for power distribution. Another electrical cabinets are motor control centers. They are special designed for controlling and protecting multi-motor loads for heavy industry applications. These electrical cabinets look almost like a switchboard or a switchgear, but because of particular necessary control and protection components for each motor, they are also not comparable with the other general distribution boards for buildings. Let's start now with the smallest distribution board for building installation, the panel boards. Panel boards, comparable to other freestanding distribution boards, are always designed to be flush or surface mounted on or against a wall. Generally accessible only from the front. Furthermore, a panel board is intended to be operated by qualified and non-qualified persons. Behind the doors, all live parts are covered by dead front covers to prevent unintended directly contact to live parts. This dead front cover is designed in a way that every person can switching on and off or resetting circuit breaker without any risk of electrical shock or an arc flash. Optionally, built in a special style frame like drawer or cut-off boxes, these specific panel boards are able to be integrated in other freestanding electrical cabinets like switchboards, we will talk about later. A panel board is also able to get its input power directly from the utility energy company via the well-known service entrance and energy meters. That is very common in family houses all over the country. In this case, the panel board is often the only one panel board in the house, and in this case it is named as service panel board. There are also panel boards with NEMA outdoor enclosure types like 3R or 4X for outdoor applications, mounted on the outside of the wall. In general applications, panel boards shall comply to the UL 67. In most cases, a standard panel board comes with ready assembled integrated main circuit breaker connected to its internal busbar system. The integrated busbar system splits the power to several branch circuit breakers, which will be field added at the time of installation, flexible to the individual application, to protect all the different loads in the house. If we want to talk now about handling electrical power in large buildings, like office buildings, over multi-flat apartments or large industry complexes, panel boards are not suitable to distribute this huge amount of energy in these big buildings. Instead of panel boards, switchboards are used for the electrical power distribution in these big buildings, for dividing a large input electrical power into smaller output currents based on the standard internal busbar system, which connects all the module boxes in the distribution section board, which included disconnect means and overcurrent protection devices. The power of all these module boxes in the distribution section supplies other downstream equipment, like panel boards located all over the building. Switchboards are often fed directly from the energy supply utility company, and in these cases the first section of the switchboard is called service section, which contain all necessary service entrance equipment like meters and main disconnect. Normally, the input power is the well-known and often used three-phase solid grounded Y infeed system with 480 voltage face-to-face and 277 voltage face to the ground. In some industry applications, also switchboards are used with an input voltage of three-phase 600 volt. Switchboards are freestanding distribution boards, and depending on the design, they may be installed next to the wall or away from the wall to permit accessibility to the rear of the switchboard, of course only by qualified persons. The access from the back side enabled an easy access to the entire busbar system. To give you an idea about the electrical power distribution of a switchboard, the main overcurrent protection device in the service section is usually a circuit breaker. In case of molded core circuit breaker, with an ampere rating between 400 and 2000 amps. In the case of an open air circuit breaker, up to 5000 amps. The maximum ampere rating of a switchboard is limited to 20,000 amps, and the maximum voltage rating is 600 volt. This is stated in the UL 891, the safety standards for switchboards. If a distribution section of a switchboard supplies a motor load and additional separate electrical cabinet is needed, which contains the motor starter for motor control and overload protection. An enclosed motor starter solution mounted on the wall and inside of each motor load is very common. These enclosed motor starters are equipped on the outside with push buttons to control the motor, and very often pilot lights to indicate the motor status. These enclosed motor starters may not be mixed up with panel boards for power distribution. We talked about in the beginning of this tutorial. The purpose of enclosed motor starter is definitely not for power distribution and shall comply with the UL 60947-4-1, the standard for industrial control equipment. In case of factories locations using many motor loads, like in the process industry, it is often desirable to control and to protect some or all the motors from a centralized location. These electrical cabinets are designed like switchboards, with an infeed section on the left side connected with bus bars to the distribution sections. But in the distribution sections, all individual motor starters, including overcurrent protection devices, are installed in the standard-sized cutout boxes for each motor, like integrated enclosed motor starter panels. We talked short before. These electrical cabinets, which are specifically designed to distribute the main power to motor loads and provide the entire motor control and protection, are defined as motor control centers in the NEC and better known as MCCs. The safety standards for these MCCs is the UL 845, applicable to single or three-phase motors up to 600 volt AC and 1000 volt DC motors. Unlike switchboards, which are limited to 600 volt application, switchgears may also be used for medium and high voltage applications. Switchgears rated up to 1000 volts are named low voltage power circuit breaker switchgears, and switchgears rated over 1000 volts are defined as metal enclosed switchgears. Switchgears are completely enclosed on all sides and containing primary power circuit switching and interrupting devices. They may have more than one primary input service section, which contains switching devices to manage different and independent energy sources. In the case of a failure of one energy supply, the switchgear will switch over to a redundancy source automatically. And the energy supply for sensitive buildings like hospitals will be guaranteed without any interruption. Normally, switchgear supplies the energy to one or more switchboards. High voltage switchgears, which distribute more than 1000 voltage, must feed a huge power transformer for generating the appropriate voltage before they can supply the energy for the low voltage switchboards. Finally, electrical cabinets, which are designed to supply, to control and to monitor electrical equipment for various purposes, are called industry controlled panels. The scope of applications can be, for instance, industrial machinery, elevator control, flame control, crane control, and so on. Unlike distribution panels like panelboards, switchboards and switchgears, used mainly for power distribution in buildings, which are standardized and tape-tized cabinets, industrial controlled panels are always customized and engineered as tailor-made solutions for specific applications. Furthermore, industrial control panels mainly contain numeric controller like PLCs, CNCs or industrial computers. For controlling all different loads, you can find often in an industrial control panel a bus bar system to bring the electrical power to converter, to controls, and to monitor electrical equipment, including overcurrent protection and all associated control circuits. The safety standards, which covers the requirements for designing all these individual industrial control panels, is the UL 508A. Now we come to the end of this tutorial. Even more helpful information about market access to North America and industrial control panels overall you can find on our websites. Benefits from tutorials, webinars, white papers, tips and tricks, and many more. Thanks for the attention, and see you again on our next online events.